Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the GPS receivers, its types and its applications. GPS receivers are available in different categories which are based on its accuracy and intended applications. This selection, which depends on the precise requirements of engineering projects with reference to data collection for the survey. So, receiver technology ranges from basic navigation devices to advanced geometric instruments, which gives the higher accuracy, and that receivers use that higher accuracy for signal processing techniques. So, civil engineering surveys which require appropriate receiver selection, that correct receiver ensures that reliable mapping, surveying, and GIS data collection. The classification of GPS receivers, which is of three grade: navigational grade, mapping grade, and survey grade, with reference to the increasing cost and precision. So GPS receivers are categorized not by brand, but they are categorized on the basis of position accuracy requirements and the method used to calculate that position. So navigational grade, that is the civil user community, which is that using for just like Google Maps, where mapping grade, that is site specific analysis, and GIS, that are the controllers for any type of receiver station, and survey grade, there that property boundary or any geodetic control that by the government officials in the land records department or land use and land cover mapping. So GPS receivers classified according to accuracy and positioning methodology, which include navigational, mapping, and survey grade receivers. Each category serves different operational requirements with reference to its accuracy, which improves as receiver technology becomes more advanced. So receiver selection affects survey quality and project outcomes on the basis of engineering applications. They are typically require mapping or any type of survey grade systems. Navigational grade receivers, that are navigational receivers, basically they are handheld or vehicle mounted receivers designed for general positioning and route finding. So what are the technical specifications for that navigational grade receivers with reference to signal, method, and accuracy? So accuracy is up to 10 to 20 meters, which is autonomous. Method which is using for that autonomous positioning, and signal is a course and acquisition on L1 frequency band. So navigational receivers are designed for general positioning and route guidance. Typical accuracy is up to 10 to 20 meters. This level is adequate for personal navigation and vehicle tracking. These receivers are not suitable for engineering survey basically. Their accuracy is insufficient for detailed mapping and construction work or any type of construction survey. So they are more suitable for recreational use or vehicle navigation only, where insufficient data for engineering data capture for huge or big projects. Next one will be the mapping grade receivers. That is the hardware designed for GIS data capture and assistance management, where demonstration of typical accuracy range is most important and focus. The technical specification on the basis of accuracy and methodology use, that is code based differential GPS, that is DGPS mapping grade receivers, uh, having the accuracy up to sub-meter to 5-meter level. So mapping grid receivers are primarily used for GIS data collection, and they provide better accuracy than standard navigational devices. Typical accuracy ranges from sub-meter to 5-meter distance coverage, where differential correction techniques are often applied to improve the precision level. These receivers are widely used in assessed management and GIS survey, where they are more suitable for utility mapping and environmental studies, and many more utility poles or man poles for GIS database establishment. Third one will be the survey grade receivers, the high precision instruments used for geodetic control and legal surveying with reference to the curvature of the earth. The technical specifications are based on the methodology and accuracy, where 10 centimeter or better accuracy up to centimeter to millimeter level also we can achieve. And methodology which is used for survey grade receivers are phase differential GPS technique, which is based on the carrier phase. So this accuracy can reach centimeter or millimeter levels also with the precision. The high precision instruments used in geodetic surveying, they utilize that carrier phase measurement technique for accurate positioning. These receivers or survey grade receivers are widely used in construction and cadastral surveys nowadays to support updated infrastructure layout and deformation monitoring. Next one will be the single frequency receivers. So single frequency receivers where depends on the ground receiver and the satellite with reference to the frequency band, like L1 frequency band with reference to 1575 megahertz frequency. That satellite signals are traveling from ionosphere to the ground receiver. So single frequency receivers track only in the L1 satellite signal band. They are simpler and less expensive than advanced receivers. So the atmospheric errors cannot be directly modeled or removed. So the limits for that are positioning accuracy under certain conditions. So these receivers are suitable for basic surveying tasks where they are less effective for high precision engineering works. So limitations, they are cannot mathematically model or remove ionospheric refraction exactly. So what are the consequences? So for single frequency receivers, that is relies or depends on external models or close proximity based stations where baselines are limited. Next one will be the dual frequency receivers. So dual frequency receivers are obviously depends on two bands L1 and L2 for ionospheric delay correction. These dual frequency receivers allows direct estimation of ionospheric delays. Atmospheric errors can be significantly reduced. That result, which is improved positioning accuracy and reliability. These receivers are preferred for engineering surveys which are most important and precise GIS and geodetic applications. What are the advantages for dual frequency? That is ionospheric free solution which provide by comparing arrival times of two other frequencies L1 and L2. The receiver models and other type of activities which removes atmospheric delays by using the delay correction. What is the result for dual frequency? That is enables longer baselines with faster ambiguity resolution and provide higher accuracy grade, which is based on some carrier phase or some cursor and acquisition code, both having different wavelengths as explained and with reference to its structure also. The concept of carrier phase measurement is that measuring the wave itself rather than the code stamp on it. So the carrier phase measurement use that GPS carrier wave instead of that code observations, and that carrier wavelength is much smaller than the code wavelengths. So this technique enables centimeter level positioning accuracy, that is precise measurements are conducted or obtained through phase tracking method. So carrier phase observations form the basic of real-time kinematics surveying, which is most important nowadays in grade survey, which depends on this methodology. With the static surveying method, the static surveying method includes that the receivers remain stationary over survey points. So receiver remains stationary over point for long duration, which is actual procedure. That point may be a ground control point. Second one will be the data is usually processed against a reference station, which improves potential accuracy significantly. That static surveying produce or provides highest accuracy up to the centimeter level or sub centimeter level to millimeter level, which is commonly used in geodetic control networks. So the static surveying method, which is most important, useful to establish geodetic control networks and tectonic plate monitoring or the geological surface exploration or somewhat subsurface exploration also. Next method will be the rapid static method. That rapid static method, which is a stationary observations for shorter durations like 10 to 20 minutes. So 15 minutes, 15 minutes will be the span where the sequence of observations with rapid occupation times. That occupation time are typically of 10 to 20 minutes. It provides faster results than traditional static survey method where accuracy remains suitable for many engineering applications. That is dual frequency receivers and good satellite geometry is used. The method which balances efficiency and precision and used for control survey or any type of construction projects. So the application for the rapid static method, which is based on the densification of control networks where time is constrained but the high accuracy is much needed. The kinematic surveying method, where the static base station and moving rover will be in the picture. The concept is on the basis of kinematic motion. So post processing, which are linking in between the static base station and moving rover. So kinematic surveying allows the rover receiver to move continuously. The base station remains fixed at a local fixed location, or just like the fixed ground control point. Continuous satellite lock must be maintained so that the signal interruptions can reduce position reliability. So the base remains static and rover moves continuously, where the constraint is that it maintain continuous lock on satellites, which gives the signal blockage forces reinstallation. The method which is useful for route and corridor surveys, then alignment of railways, highways, and many more. Signal interruptions can reduce positioning reliability, and that mapping linear features are most important nowadays with reference to the highway construction or updating the existing highway or railway planning. Real-time kinematic, that is RTK, where the RTK provides real-time differential corrections from any type of base station. These corrections are transmitted instantly to rover receivers. Position accuracy is up to the range of 1 to 3 centimeters with reference to the real time, which is available immediately on the field. This real-time kinematic is widely used nowadays for the constructional layout and monitoring for land use and land cover department, where engineers depends on that real-time kinematics for highly accurate field measurements. Accuracy, so we have to maintain or achieve the accuracy and precision on the basis of some instruments or advanced technologies, that is navigational, mapping, and survey. Here the navigational receivers, mapping receivers, are survey receivers. So navigational receivers which provide approximately 10 to 20 meters accuracy, they are suitable for general navigation activities. Mapping grade receivers based on DGPS, they improve the accuracy up to 1 to 5 meters. These systems are commonly used in GIS applications. And the survey grade, that is real-time kinematics receivers, achieve centimeter level precision. They are essential for engineering and cadastral survey point of view. Means with reference to the size, if navigational receivers are of the size of house, then the mapping receivers are of the size of car, and the survey receivers are of the size of a coin. So selecting the correct receiver, which require balancing cost against specific accuracy requirements. With the civil engineering perspective, that is the urban applications or civil engineering applications for urban planning, photogrammetry, and construction activities. GPS receivers support construction layout and infrastructure development to accurate positioning, which improves project execution and the quality of construction and management. GIS and photogrammetry projects require reliable ground control points, so that the GPS receivers which provide precise georeferencing information, whereas the urban planning and asset management which depends on the spatial data collection, and that GPS technology which is most useful and improves decision making procedure and the project management policies. The summary of receiver types and its methods. So GPS receivers are categorized as navigational, mapping, and survey or survey grade systems. Each category offers different levels of positioning and its accuracy also. Survey methods include static, rapid, kinematic, and real-time kinematic techniques. These are selected on the basis of the project requirements and the precision required or need. The accurate GPS technology, which is most essential in nowadays for modern civil engineering construction activities. It supports surveying, mapping, GIS, and infrastructural development. So the receiver choice is dictated by the specific precision required for the project future scope. Stay tuned, guys. Happy learning.